from YUMIN Primary School.
My name is Guo Cheng Guang, Primary 2, also from YUMIN Primary School.
This lesson is Calculus, Chapter 4, Further Differentiation. This lesson will look at this question. For this question, here we have a rectangular sheet, okay?
And we will use this cut. Okay,
so here this
So
rectangle.
we'll cut off 4 squares. If we don't cut off,
Is like this, okay?
yes, if we don't cut off the 4 is a rectangle, then
So for this, we
Okay.
need to tear off the 4 angles. Okay?
so like this.
So like this, here we have the 4 angles torn off, right?
Okay.
So for this,
After that, we'll
you need to
go.
fold these up.
Then we found out it's a tray, and if it's a rectangle here, shorter, higher, in no use, it always follow the short one. If you put one high, one short, it will always follow the short one, and if you put it until the high one, it will flow away.
Okay, so for this is what a tray is like, right?
Yes, give a paper example, it will be like this.
Okay, yes, it will be like this. There are these angles that is cut off.
Yes, if you open it, it will also look the same, except for they're just bigger.
Okay, so for this is what a tray looks like, right?
Yes,
So right now we'll have one example like this, okay?
okay.
Okay, so let's just put this over here. Okay, so right now, tell me, what are we finding?
We are finding the maximum value of the tree.
Okay, yes. So we are finding the maximum value of the tray. That means you have to find this part,
Yes,
the height, and this part, right?
and if you only say minimum, it can be just one drop. Something like water.
Okay, so for this, because that we're finding the maximum volume, and remember these are the same actually. What the same is this part and this part, this part, this part, right?
Yes,
The height is
because
also the
it's a
same.
rectangle. The rectangle.
Okay, so for this, we need to know how to find the volume, right?
Okay, so since it's an x,
So for this volume, you need to find this part.
yes, base.
So the base area, right?
Okay, so this part, this will be 25.
It's inside here.
Yes,
Can you point it?
here.
Well, let me show you. It's over here. This whole
Yes.
area, right?
Yes.
At first,
So area is bigger, the volume is smaller.
this is like this, right?
Yes.
So you need to find this side, which is actually this side. Then you need to
Then
find
it's 25 minus
this.
2x. Then over here will be 40 minus 2x. First we will find the area, but we can straight away use volume. First we find the volume, then we'll find
then what do you need to times?
x.
Yes.
And
Why
after that,
x?
you will need to use the first derivative, then we'll find x, then sub.
Okay, why is it x?
It's x.
What is it? What is x? You realize that x, when you actually fold it, it's actually the height, right?
Okay.
X is the height. So that means this is the base area times the height.
So that means here is x.
Okay, so let me show you. It is
over here.
This part, right? Because then this
Yes.
square is cut off, so it is over here. Then when you fold it,
When you fold it, it will be like this.
so
The height is here.
like this. This is x, right?
Yes.
Over here, this is x. So when you fold it, that's actually x. Correct?
Okay. Here.
Okay, so that is why this height is x.
Yes.
So right now, can we start on this question?
Okay.
To find the maximum volume, we'll have to find the first derivative, right?
Okay.
For this first derivative, we
Anyway.
can actually times these
There's
together
another
first.
name for this. Other than the tray, you also can say the open.
That can also be an open cuboid, right?
Yes.
So here this is a minus 50 plus 80, 130 x squared. Then here you need to plus the 4x cubed. So here this is a 1000 minus, this is a 260x. Then you get plus 12x, right?
Wait, where's your square?
Okay, yes, correct. So for this,
Now we'll let the first derivative be 0 and we'll find what is the x.
so let first derivative be 0 and find x, right?
Yes?
But for this x, okay, let me just work it out here, okay?
Okay.
First we can put a 4 in front. Here is 250. Then you need to minus 65x, then plus 3x squared, right?
Okay.
So for this we can actually
Equals 0. Is the equation?
okay, yes, this is 0, okay?
Okay.
Then for this x, this is, first here is a negative 65.
Okay.
Is it
Okay.
negative or positive?
It's negative, positive.
Okay, yes, because that here is actually a negative, so this becomes positive, right?
Yes.
Then here is a plus or minus, and this is square root. Because that inside here, which square? This square, right?
Yes.
So negative, negative, positive again. So we'll just need to write 65 squared.
Okay.
Then we'll have the minus 4a, which is actually here, c.
Okay.
Then this is over 2a, right?
2a.
So this is actually a 6.
Okay.
Here we have two answers.
50 over. We will reject the first answer. Because if you don't reject the first answer, this will be
Okay, so if x is actually a
a
50 over 3.
negative. Here it will be a negative, and negative is not correct.
Okay, 50 over 3 is already like nearly 17, right?
Yes.
If it is already 17, okay, let's just count at 16, okay? Even if it is 16, 16 times 2, 32. 32, how are we going to fit this 25? And also, there's no such thing as a negative length.
Yes.
So this one we need to reject 5. It is possible, right?
Yes.
And this is the only case that we can choose. And remember, this is cm.
Why is it 5? Because it's 1 over 1.
Okay, so for this, well, this is a 30 over 6.
Yes.
At first, when we calculate this, actually a 30 over 6, right? Okay, so for this x is 5. Find the second derivative.
Okay.
So for this is a negative 260 plus this is 24x, then you need to sub x, that is 5, right?
Right.
So this is a negative 260 plus
Actually, this one you can, the square don't cut, because if you cut, it can open. If you don't cut here, can stick, and another can stick. So
Okay,
it
so
will open.
this second derivative is smaller than 0, right?
Yes.
So we are
And
finding the
we're finding the maximum, and
for this maximum area, that means we'll sub 5 into this part, right?
yes.
So right now you need to know what is 25 times 13.
So
Okay, remember this is 3250. This is 3250, then you need to add 4 times 125.
4 times 1 to 5 is
500.
500.
Okay, so for this, first you minus these two. So what happens?
So
These two minus is actually a 1750. So 1750, this is a 2250, right?
okay.
And here you have the units, right?
Summarize.
Okay, so for this, remember there is many types of these rectangular sheets. You can make
Okay.
one with cover and with cover, and you can take
then
it
we
down.
never say why does and does, so that it's 5, right? So 40 minus 2 times 5, 10. So 40 will be a 30, and up here will be a 50. And remember, if the area is bigger, the volume is smaller.
Okay, yes, correct. Like for example, if your base is very big, what happens?
And you know why I say best to like this? Wonder if like this you put some cookies. Will the cookies slide off?
Okay, so for this, you need to find a way to make this need to be higher, right?
Yes.
These sides need to be taller, but not too tall until that the base is too small. So that means this have to use the correct choice, right?
Yes.
Like not too big, not too small.
Just
Correct?
right.
Yes. Okay, so this is actually something like a designer
Yes.
designing, right?
Yes. Designer designing.
Okay, so for this is how to calculate the volume. Then we expand. Then we find the first derivative.
Then we will let the first derivative equal 0 and find the s. Then the second derivative, then the maximum.
Area.
I mean volume.
Okay, there are two cases, right? What about the surface area? Okay, so there are
Okay.
actually different cases, right?
Okay.
So to understand for this
Okay.
question, okay, so in the next lesson we'll continue with this, okay? Okay?
Okay.
So can we end?
Okay.
Okay. Bye.
我怕才录了8分钟。
录了10几。